Assalamualaikum and hi, welcome to my video. I want to present my project which is about My name is HAFIDZI bin HISHAMUDIN and you can call me Harith. Windshield augmented HUD with surround parking system, or called as YSP system, is the title of my final year project. Dr. Ahmad Sufri Azlan Muhammad was my supervisor during the YSP system development. He was helping me a lot during the development of the YSP system. Then move to the next section, which is the introduction of this project. This project is a collaboration with DD Sendirian on HUD, a company that manufactures car dashboard for many cars in the world, and Proton is one of them. The company was proposed to me to develop two modules for the project, which are to straighten up HUD's projectile on the HUD screen that will be embedded on the windshield, and creating bird's eye view around the car on the HUD screen. Therefore, I plan to develop the project as a car simulator to accomplish the proposed module by the company. At the end of this video, I will show the project demonstration to prove the concept of this project. Then move to the next section, which is the problem statement of this project. There are three problems that have been prompted me to create the YSP system. The first problem is limited vision. This is due to the blind spot that happens when the driver was driving the car. The blind spot was making the driver difficult to view it, and it can easily make the driver involved in the accident. The second problem is parking. The driver was finding it difficult to enter the parking box, so they need to ask the passenger to assist he or she in determining whether or not the parking is on the parking box. Sometimes, when the driver was alone, he or she need to exit the car to check whether the car was in the parking box or not. The third problem is image distorted. This is due to the surface of the windshield that was not flat. That makes the driver was hard to view the image, which has been projected by the HUD. Then, move to the next section, which is proposed solution of this project. There are two modules on this project, which are the HUD module and monitor view module. The HUD module has one submodule, which is the HUD screen. This is to create a warping of the image, so the projectile image from the HUD will be straightened up. After that, the monitor view module has three submodules. The first submodule is bird eye view. There will be 5 cameras that are going to be installed in a car. One camera will be mounted above the car and will provide a bird's eye view. The remaining 4 cameras will show the surrounding view, with one camera mounted on the front bumper to see the front view, 2 cameras mounted on both sides left and right under the side mirror to see the both side view, and 1 camera mounted on the back bonnet to see the back view. The second submodule is the proximity sensor. The sensor is to detect the presence of any occlusion that are nearby with the car. It will give the HUD an alert when it detects any presence. The third submodule is parking assistant. It will provide an assist for the driver in parking the car by detecting the parking space. Then move to the next section, which is the objective of this project. There are two objectives of this project. The first objective is to develop a simulation that will allow the driver to watch the live video around the car, which parking assistant get an alert for occlusion using sensor, and have a single bird eye view that will be projected onto the windshield. The second objective is to integrate the camera system to the display of the HUD projected to the windshield to reduce the warping in the image. Then move to the next section, which is the system module. There are 3 system modules on this project. The first module is a HUD screen that will show the image of the pedometer, bird eye view, sensor alert on the windshield. The second module is the parking assistance system. On the reverse mode view, it will display a parking box to help the driver in parking. The third module is the nearby detection system. It will detect the nearby object, and if something has been detected nearby, it will send an alert to the HUD screen. Then move to the next section, which is the system architecture. This is the system architecture diagram for the WAH-SP system. The player or the driver need to using their PC or laptop to access this simulation game. The driver also needs to connect the input device, which are the steering controller. For this project, I was using Logitech G25 racing wheel to make the car moving. After that, the driver will enter the game. This project has been developed by using the Unity game engine and also using the Vehicle Physics Pro as a game asset. The game asset was providing the car model for me to embed all the functionality that I was proposed to this project. Therefore, the driver will gain experience by viewing the sensor alert, bird's eye view, and parking assistant on the HUD screen embedded on the windshield. Then move to the next section, which is benefit. There are 3 benefits when using this project. The first benefit is the focus. This allows the driver to concentrate on the road since the HUD is embedded in the windshield. The second benefit is alert. This is to ensure that the driver is aware of anything that was nearby with the car, particularly in the blind spot. The third benefit is image straightened up, so the driver can view the image clearly on the HUD screen. Before I wrap up the video, let's take a look at the project demonstration. This is the WAH-SP system, which will act as a car simulator. Since this game can only be played using the steering controller, therefore, the driver will see the instruction to participate in this game. To start the game, the driver must press the button. The driver can then move the car by changing the gear mode and steering direction. When the gear is changed to reverse mode, the camera will switch to a back view and the driver can see the parking box exists. In this game, the driver can park their car in one of 2 locations, a parking lot or a parking complex. As its camera will show the parking box exists, the driver will get exist when parking the car. Therefore, the driver can refer to the camera view. The car can be turned off and restart. When another car or object is nearby, the driver will receive an alert. When the driver clicks the HUD menu, it displays the project description, the control button, and a description of each function of icon and color on the dashboard and aid. When the driver presses the options menu button, several options are displayed. The driver has the option of restarting the game, resetting the car position, or exiting the game. If not, the driver can continue playing the game.